some vocabulary we already know, okay, or reviewing some vocabulary from 5th grade. So, the first word we're going to talk about today is a factor. Ms. Boxie wants you to take the whiteboard, each individually take a whiteboard, and give me your definition of a factor. 1 minute to do so. Give me your definition of a factor. In your own words, what is a factor?
Multiply to another in the multiplication problem.
So they're practically the same thing because you said that it's a number to multiply to get a number that you multiplication problem, and I just said it was a factors are numbers you multiply to get a product. So what did you put, a factor is a number that you can multiply to get a number. Yeah, because you can switch them around.
Okay, let's bring it together. Who would like to share the definition of a factor? What is a factor in your words? Cameron?
A factor is a number that you can multiply by another number to get a product.
Agree or disagree, class?
I agree.
Very good. Would anyone like to add on? Pretty good definition of a factor, correct?
Yes.
All right, so a factor, she said, is a number that you multiply times another number to get a product. All right, so what would be a greatest common factor? What would the words greatest common factor mean? Or what is a greatest common factor? Perry?
The largest factor that two numbers have in common.
The largest factor that two numbers have in common. What do y'all say about that?
Agree.
Very good, very good. Ms. Boxie wants you to take your whiteboards and find the GCF of 18 and 20. The GCF of 18 and 20. All right, what did you find for the GCF of 18 and 20? Sophie? 2. How did you come up with that answer?
I listed the multiples of 18 and 20.
You listed the multiples of 18 and 20?
Not the multiples, sorry. The factors of 18 and 20.
Okay, how did you do that list? What did you do to make that list?
I did 1 times 18, and 2 times 19, and then 3 times 6 for 18.
Okay.
And then I did for 20, 1 times 20, 2 times 10, 4 times 5.
Okay, did anyone do it differently to come up with the GCF? Did anyone do it differently? So everyone made a list?
Yes.
Okay, did you put your list in anything in particular?
A T-chart.
A T-chart. Did everybody use T-charts?
Yes.
For the most part? No, William, you didn't use a T-chart. What did you do?
I put them in order of increasing value.
Okay.
1, 2, 3, 6, 9, and 18 for 18.
Okay, very good. So 2 different methods. One person just made a list, or some of you just made a list, and some of you used a T-chart. Good. All right, so let's move on. Since we have a factor and we know what greatest common factor is, let's move on to a multiple. Use your whiteboards to write in your own words the definition of a multiple. What is a multiple?
A multiple of the number in a list. For example, 12, 24, 36, 40, ...
A multiple is a number in a list. Okay. What did you put, Ethan?
Multiple is the
What'd you put?
product of a multiplication problem.
I put that too. I put a multiple is the product of a multiplication set. I don't think it's always in a list because you could put 1, 2, 3, 4, 5 in a list and they wouldn't all be multiples. Yeah.
Come back together. Let's come back together. In your words, who would like to share what is a multiple? What is a multiple? Jack?
A multiple is a number that is the product of two factors.
He said a multiple is a number that is a product of two factors. So in other words, can we say that a multiple is a product? Yes, a multiple is a product. Very good, very good. And as I walked around, that's what most of you guys had. A multiple is a product. So, if I'm asking for the least common multiple, what am I asking for? If I'm asking for the least common multiple, Jesse, what am I asking for?
A number that can be multiplied to the same number by two different numbers.
A number that can be multiplied to the same number.
And then go for each.
Okay, would anybody like to add on?
The least common multiple is the lowest number that you can get by multiplying two numbers.
Okay. Anyone else?
A multiple is a number that is doubled, tripled,
Well, we're looking, keep on.
a number that is doubled, tripled, and so on, and just as long as the number can go in the bigger number, like multiplying it times 2, 3.
Okay, but we're looking for the LCM. We're looking for the definition of LCM. So maybe that's a multiple, but what is the least common multiple? Luis?
The least common multiple is the multiple that is found in two or more numbers.
Okay, and it's not just any number that's found, it's the what class? Smallest. It's the least. And notice Luis did say two or what? More numbers. That's very good. Well, today's lesson, we are going to find numbers to satisfy different constraints of LCM and GCM. So we're going to go a little bit deeper. We're not going to just find the LCM and GCF, which we sometimes call the GCF, which is the greatest common factor, and the LCM for short for the least common multiple. So today what we're going to do, once again, is we're going to find numbers that satisfy different constraints. We're going to go a little bit deeper than just finding the LCM or finding the GCF. All right, let's take a look at some student work here. All right, here we have Zach. Zach found the GCF of 8 and 20. How did Jack do that? Let's take a look at Jack's work to find the GCF. What did he do there? Zach.
He listed the factors from smallest to biggest.
Okay, he listed the factors from smallest to largest. Okay, what advice would you give to Zach for the GCF? Looking at Zach's work, do you know the GCF? No. So what does Zach need to do here? Cooper?
He needs to circle the greatest common factor.
He needs to somehow identify the what class? Greatest common factor. Other than that, any more suggestions for the GCF? Yes.
Circle the factors they have in common.
We could also circle the factors that they have in common. Good, good. Let's look at the LCM. He did something similar. What suggestions you would give to Zach for the LCM? Miranda? Circle the ones that are in common. Does he have any multiples that are in common here?
No.
So that means that 8 and 20 do not have an LCM?
No.
Okay, Meredith?
He needs to extend his numbers.
Very good. He needs to do what, class? Extend his multiples. If you ever come to a point where you do not have a common multiple, then you need to extend your multiples. Do you guys understand that?
Yes.
Okay, we can always have a common factor, right? If we don't find any other numbers that match, what would be that common factor? 1. 1 is a factor of every number. Here, what Zach needs to do is to continue his multiples. So what would be the LCM of 8 and 20? Kaden?
40.
40. Agree or disagree?
Agree.
Good. Let's look at another student's response. Okay? The numbers here were 8 and 20. Let's take a look at what Amy did. Who notices what Amy did? Or who can tell me what Amy did to find the GCF here? What did Amy do, Sydney?
She made a factor tree to organize her factors of
Very-
8 and 20.
Very good, okay. When we use a factor tree, do we get regular factors?
No.
What type of factors do we get?
Prime.
Prime factors. So look, she did the prime factorization for 8, which she got what?
2 times 2 times 2.
And then she did the prime factorization for 20, which is?
2 times 2 times 5.
And notice, she used a Venn diagram to organize her information. Okay? Why do you think she put 2 2s in the overlapping section?
Because in most of the statements for the prime factorizations, they both have 2 2s.
Very good. They both have 2 2s. So guess what? What's 2 times 2?
4.
So guess what this overlapping section just gave Amy?
Her greatest
The greatest common factor. Very good. The overlap is 2 times 2, which is 4. And notice, not only did Amy show it, but she also explained it. Now, she says the LCM is 2 times 2 times 2 times 5, which is 40. Okay? How did she get 2 times 2 times 2 times 5?
She just multiplied all the numbers together.
Very good. Look at the Venn diagram. We have the 2 times 2, and then we have times another 2 and 5. Very good. So this is another method that you can use. Okay? What would be the advantages of using the prime factorization? Or disadvantages? Okay? What would be the good thing about using this, or when would it be more useful to use this strategy rather than the other? Amelia?
You don't always have to list all the factors
So what's so good about that?
because it's faster to do and you don't have to list all the factors, and whenever you're listing all the factors it takes you more time.
Okay, but what about if my number is 2?
Then you only have one factor.
Very good. So do you think this method would be best at that time? Now, not one factor. 2 has how many factors, class? 2. 1 in itself. Do you think it would be more beneficial to use a factor tree then? No. So when would it be more beneficial to use factor trees and prime factorization?
I think it would be more beneficial if you would have large numbers.
Agree, class, or disagree?
Agree.
All right, very good. Well, today what you're going to do is you're going to break up into groups of 2 or 3. And each group will receive this grid. Okay? This grid has both GCF and LCM. Okay? You have your GCF in the columns, and you have your LCM in the rows. One has been done for you already. Okay, you have 2 numbers, 12 and 16. So here, notice the GCF is missing. You would have to fill that in. The LCM is missing. You would have to fill that in. And from there, you would have to fill in all of the missing cells, including the missing GCF or the missing LCM. Okay? You're going to do that with little cards that you're going to be given. Now, some cards will have 2 numbers that are there. Some cards will only have 1 number. That's where the constraints come in to play. Okay? So, in your groups of 2 or 3, agree on a strategy and work together to complete the grid. So you're working together. First, you need to come up with a strategy. You need to fill in the missing numbers in the shaded sections and decide which cells the sets of numbers on the cards belong to. You can do either or. That's when you come up with a strategy. If a card is incomplete or blank, you need to complete it. Each cell should contain 1 card. You must all agree on the completed grid and be able to explain the position of each card in each cell on the grid. Once you're able to do that, Ms. Boxie will let you go ahead and glue the cards on the grid for your finished product. Okay? Are there any questions? You may use the whiteboards to do any calculations that you may need to. The grid and the cards are at the back table. If there are no questions, you can begin.
Alright, so we have to find the greatest common factor and the least common multiple of 12 and 16.
First.
Okay, so I think what the chart is saying is that we're going to factor and find the least common multiples of these, and then we'll put them there.
So do you want to get greatest common factor or least common multiple?
Let's do greatest common factor.
Okay.
Okay. What do you want to start with?
12 and 16.
Okay.
That's what we have.
So,
Okay, let's look at 12 and 16. What can we find a greatest common factor for 12 and 16? And then we can be able to fill in that spot.
so 12 times 1, and then 6 times 2, and 3 times 4. And then 16 times 1,
Something with a factor.
8.
4 does.
The greatest common factor is 8 and 4.
Wait, no.
So,
Greatest common factor. Okay, so 4 is, 6 is, 4 is.
Wait, 6 and 3? 16 and 3, that can't be divided. So that goes right here.
Right. No.
And what's,
Yeah. Because
Okay, what's the greatest common factor of that? Greatest common factor is 16 and 3. 16, 32.
1, it would have to be 1.
it would be 2 greatest common factor.
Oh.
2 because 4
Wait, what are the numbers? 4 and what? 12?
4 and 8, their greatest common factor would be 4. So if you wanted your greatest common factor to be 2, it would be 4 and 2.
Well, then will the least common multiple be 12? It wouldn't be, right? Because 8 is a multiple of 4.
Okay, well let's find out the. Okay, so then maybe
I think that
it
might
could
be
be a
there.
48 one.
16 is 3.
So let me ask you something. Let's pick a strategy. Do you think it would be easier to do 2 numbers that are already there, or 1 number that's there and 1 that's not?
2 numbers that are already there.
Okay, so what should your strategy be?
Doing the numbers that are there and then find the spots for the ones that have.
Perfect, because only 1 card can go in each spot. Good, good, keep working.
So you would be 3 and 8. Let's do that one. So the only thing that equals 3 is 3 times 1. And then 8 is 8 times 1 and 2 times 4. So the only thing they have in common is 1. So it would have to go either here or here.
24, 3 and 8. 3,
Yeah,
6,
8 times
9.
3 is 24. So that's 3 and 8.
3 next.
Yeah.
The least common multiple.
Okay. So let's do the next one.
You gotta do one.
Right.
that fits that category. Okay, so you cannot use those same numbers to fit that category. Okay, good job. Who's your Aaron monitor? Aaron monitor will get one more. Tell me what you would do here.
Well, you know that it would have to have a 1 and a 2 as a factor because it ends in an even number.
Good, that's using your divisibility rules. Good. Good. What else do you know?
The greatest common factor is 2.
And what else?
That it's got to be an even number.
6 times 8 equals
Work on, use what you know. Y'all have some good strategies there. You know the GCF is 2, and you know that it has to be an even number because it's a multiple of 8. The LCM is 48. Okay?
There's already a 4 times 8, 6 times 8. 16.
Your attention, please. So let's talk about what you just did. Okay? Let's talk about some methods that you used to complete your grid. Because as Ms. Boxie said, some of the cards you had, some of them had both numbers. Some only had one number. And also on your grid, you had some numbers that were missing. Okay? So, what methods did you use to help you to find the GCF and the LCM? Cameron?
With the cards that had both numbers, we did the multiples and the factors of both of the numbers and see if they matched up.
Okay.
On the column with the 1, I knew it couldn't be an even number because those would have just been 2. So I put except for 2. I just put odd and even numbers because they wouldn't add up. They wouldn't be another number. They were even and even or odd.
Very good. So do you think that lesson on odd and even that we did earlier in last week, do you think that helped a little bit?
Yes.
What else helped that you had prior knowledge of? What else helped that you had prior knowledge of? Luis?
The
The divisibility rules. Very good. Because as I walked around and listened to some of you, I also heard that you were saying, well, it's not divisible by 2, or it has to be divisible by 2 because the multiple is also an even number. Okay? Which cells did you find the most difficult? Which cells did you find most difficult or made it a little bit more difficult to solve? Morena?
With only one number.
Okay, she says the cards with only one number.
The impossible.
The impossible. Okay, which one was impossible? Which one was impossible? William?
The one with the greatest common factor would be 8 and the least common multiple would be 12.
Very good. How did you know that this would be impossible? How did you know that would be impossible, William?
We just figured out the rest of the grid and the impossible was the last one left over. So.
Okay, so he used, I guess, process of elimination. Now, who can prove to me that it's impossible?
8 times nothing that's a whole number will give you 12.
Okay, she says 8 times no whole number will give you 12. But does it have to be 12, or does the LCM have to be 12? Well, in order for the LCM to be 12, then it must be a what? A multiple. Well, 8 has to be the what? Factor, and 12 would have to be a multiple. Very good. That's what makes it what? Impossible. Did anyone else think of something there where you knew it was impossible? I had a question that I came up with for that group. My question was, does the GCF and the LCM have any type of relationship? Take a look at your cards. Does the GCF and the LCM of a set of numbers have any type of relationship? If so, let's discuss that relationship.
By multiplying the two numbers.
Meredith's talking.
By multiplying the two numbers, like, no, I was thinking of something else.
Thinking of something else, okay?
Each row had, not each row, but the first row had all of them with 4 except the impossible. The second row had all of them with 8, and the third row had all of them with 16.
Okay, so can we say that the GCF and the LCM have some type of relationship? Yes. Notice that the GCF is also a factor of the what? LCM. Okay, factors and multiples are related, folks. Remember when we started out today's lesson, we said that it took 2 factors to make a product. And we said that product is also a multiple. But that multiple is also divisible by that factor. That's what makes that 8 and 12 impossible. Okay? Now, let's talk about something that we could have done different in this lesson. Okay? Actually, we added a little extension. Tell us what you were doing over there, Jack.
We had to figure out with
Can you help them out, Cooper, and tell them what you guys were doing over there or attempting to do?
We were attempting to find the answers to the numbers. We were attempting to find the greatest common factor and least common multiple with different numbers.
Very good. So that is an extension. That's something else we could have done different with this lesson. We could go back after you have found your the numbers. You could go back and try to see if there is another set of numbers. Okay? Tomorrow what we're going to do is we're going to go even deeper. Tomorrow we're going to look at GCF and LCM in real life situations. So therefore you'll have to know the difference between the LCM and the GCF. Okay? Are there any questions or anything that you would like to add?
no matter.
All right. Yes, sir.
My partners on the LCM we found all of the factors of each number, so when we couldn't find out something, we find a number in one of them and use them as in one of the blanks.
We'll say that again.
My partners and I, we found the factors of 48 and 24 and 12 to find the other number in the blanks because we couldn't figure it out, like this number.
Mm-hmm.
We found the multiples of this and we put that there and we found the
Very good. Listen to what Anthony just said. Anthony said he and his partners found, or he and his group members found that this number was what, class?
24.
And this number was?
48.
So they went in and they found the factors of 24 and 48 to find the missing numbers. Does that make sense?
Yes.
Did anybody else use that strategy? Okay, that was a good strategy or something to think about next time. That's how factors and multiples are related. If it is a factor, then you can take the multiple and it can go into it without having a remainder. Okay? Any questions? Very good observation. Very good. All right.